Hello everyone, welcome back to my channel. My name is Larry, studying in Sri Venkateswara College of Engineering. Today we are going to discuss about the subject mathematics. The topic what we are going to see today is vector calculus. The content what we are going to see today is definition of vector and scalar, application of dot product and cross product, definition of some topics. First, let's look into the vector calculus. What is definition of vector and scalar? Vector. A vector is a quantity that has both magnitude and direction is called vector. Example for vector: velocity, acceleration, force, etc. Scalar. A scalar is a quantity that has only magnitude but not direction is called as scalar. Example for scalar: weight, length, etc. Now let's look into the second topic, that is dot product and cross product of two vectors. First, dot product of two vectors. If a bar is equals to a1 I cap plus a2 j cap plus a3 k cap and b bar is equals to b1 I cap plus b2 j cap plus b3 k cap, then the dot product of two vectors, that is a bar dot b bar, is equals to a1 I cap plus a2 j cap plus a3 k cap in dot b1 I cap plus b2 j cap plus b3 k cap. That gives a1 b1 plus a2 b2 plus a3 b3, where I dot I is 1, j dot j is 1 and k dot k is 1. Next, cross product of two vectors. If a bar is equals to a1 I cap plus a2 j cap plus a3 k cap and b bar is equals to b1 I cap plus b2 j cap plus b3 k cap, then the cross product of these two vectors is defined as a bar cross b bar is equals to modulus of I j k. First row, second row a1 a2 a3, third row b1 b2 b3. Now let's look into some applications of dot products and cross product. The dot product and cross product are both operations used in vector algebra with various applications in physics, engineering, computer graphics and more. Application of dot product, that is scalar product. The dot product is used to find the projection of one vector onto another and to calculate the angle between two vectors. Example, in physics, it's used to calculate work done, determine the components of a force acting in a particular direction, or find the angle between forces acting on an object. Second, the application of cross product, that is vector product. The cross product is used to find a vector that is perpendicular to the plane formed by two given vectors. It's also used to calculate torque, angular momentum, magnetic fields, and in 3D graphics for generating normal vectors. Example, in physics, it's used to find the torque exerted by a force determined or direction of magnetic field in electromagnetism and find the angular momentum of rotating objects. Now let's look into some definitions of some topics. First, unit vector. A unit vector is a vector with a magnitude of 1 and is used to indicate the directions. The mathematical formula is a cap is equals to a bar divided by modulus of a bar. Example, if a bar is equals to 2 I cap plus 2 j cap plus 1 cap, then find a cap, that is unit vector. First, modulus of a bar is equals to root of 2 square plus 2 square plus 1 square, that is root 9. Root 9 is nothing but 3. A cap is equals to 2 I cap plus 2 j cap plus k cap divided by 3. Then the next, angle between two vector formula is cos theta is equals to a bar dot b bar divided by modulus of a bar into modulus of b bar. Second, gradient of a scalar. If phi of x comma y comma z is a continuous differential function, then gradient of phi of grad phi is denoted by grad phi. Formula for grad phi is equals to dou pi by dou x I cap plus dou pi by dou y I cap plus dou pi by dou z k cap. Example of gradient of scalar is if the potential of a scalar field is phi is equals to 7x plus 3y minus 2z, find the gradient of the field. Solution. Phi is equals to 7x plus 3y minus 2z, where we have to find grad phi. Grad phi is equals to dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap into 7x plus 3y minus 2z. First, we have to differentiate the whole term with the phi term with x and with y and with z. Then the grad phi is equals to 7I cap plus 3j cap minus 2k cap is the solution of this problem. Third one is divergent of a vector, that is nothing but div v. If v is equals to v1 I cap plus v2 j cap plus v3 k cap, where v1 v2 v3 are function of x y z, then the divergent of a vector is denoted by div v. The formula of divergent of a vector is del dot v bar is equals to dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap into v1 I cap plus v2 j cap plus v3 k cap, where del dot v bar is equals to dou by v1 x plus dou by v2 dou y plus dou v3 by dou z. Example of divergent of a vector is if f bar is equals to e power x cos y plus e power x sin y plus z. Here f1 is e power x cos y, f2 is e power x sin y, and f3 is z. Now del dot f bar is equals to dou by dou x plus dou by dou y j cap plus dou by dou z k cap into e power x cos y plus e power x sin y plus z. Now the first dou by dou x into f1 plus dou by dou y into f2 plus dou by dou z into ft. f1 should be partially differentiated with respect to x, f2 should be partially differentiated with respect to y, and f3 should be differentiated with respect to z. Then the result is e power x cos y plus e power x cos y plus 1, which gives div f bar is equals to 2 e power x cos y plus 1 is the solution of this problem. Next, fourth one, curl of a vector, that is nothing but curl f. If f is equals to f1 I cap plus f2 j cap plus f3 k cap, where f1, f2, f3 are the function of x, y, z, then the curl of f is denoted by curl f. Formula of curl f is equals to del cross f bar in modulus I j k, first row, second row dou by dou x, dou by dou y, and dou by dou z, third row p q r. Then example of curl of a vector. Determine if the vector field f is equals to yz square I cap plus x z square plus 2j cap plus 2xyz minus 1k cap is conservative. Solution: curl f is equals to I j k in modulus dou by dou x, dou by dou y, and dou by dou z, and pqr is the formula of curl f. Next, curl f is equals to I j k dou by dou x, dou by dou y, and dou by dou z, where p is nothing but yz square, q is equals to xz square plus 2, and r is equals to 2xy minus 1. Now we have to differentiate with a matrix form, that is I into differentiate dou by dou y with respect to y, dou by, that gives 2xz minus 2xz I cap minus 2yz minus 2yz j cap plus z square minus z square k cap, which the resultant is 0. Therefore, the given vector field f bar is conservative. Thank you for watching this video.